Hello everyone, welcome to this video. In this video, we'll be solving this question which relates to our previous question. So let's see how and what is this question, how can we solve it. So here they're asking you have to first of all compute the order of the group U4, the order of group U10 and the order of group U40. So you can very easily compute the orders. Let's first of all compute the orders. So what is this group UN? This is a multiplicative group where we have all the members less than n which are relatively prime to n, right? And we have the group operation as multiplication modulo n here, correct? This is what is this group UN. So therefore what is U4? U4 contains all the elements less than 4 and relatively prime to 4. They are 1 and 3. So because it contains 2 elements, hence its order is 2. Similarly, for U10, we have the numbers which are less than 10 and are relatively prime to 10. They are 1, 3, 7 and 9. Hence, the order of U10 is 4 because it contains 4 elements within it. Now, what is the order of U40? U40 consists of all the elements which are less than 40 and are relatively prime to 40. So, in total, we have such elements as 16 elements. You can pause the video and calculate all of them one by one, starting from 1, then 2, 3, 4. Now because you see 40 and 2, they do not have GCD equal to 1, they have GCD equal to 2. Hence all the multiples of 2, that means all the even numbers would be eliminated from here. So we only have to check for the odd numbers in this particular case, right? So you can count all the numbers. They are 16 in total. Hence we have the order of U40 as equal to 16, correct? Okay, now once you have this thing, so here we previously have conjectured that whenever we have the group URS, where R and S, they are different integers, right? Then the order of URS would be equal to the order of U of R multiplied with the order of U of S. Now this conjectures fail here. Why? Because the order of U40 is 16. However, the order of UR, that is U4, 4 into 10 gives you 40, right? So the order of U4 is 2 and the order of U10 is 4. 2 into 4 is 8, which is not equal to 16. They do not match. So therefore our conjecture fails. So this thing is not true in general. This becomes a counter example here. So that is what they are saying. Do these groups, they provide a counter example to the answer which you have provided to the previous question? Yes, it provide a counter example, right? Hence our conjecture should be revised. Now they are saying revise your conjecture then. Now for revising the conjecture, you have to make a certain observation here. What is that observation? What is that thing that you observe in the previous example but it is not present here? Do you find something? If that is so, that becomes our, based on this observation, this becomes our condition which would be included with our conjecture, that this conjecture would be true whenever we have that particular condition, correct? So let's have a look at the examples which were there in the previous question. We had groups U3, U4, U12 in the first case. You see 3 and 4, they are relatively prime to each other and their product gives you 12. 5 and 7 are also relatively prime to each other. Their products give you 35. 4 and 5 are also relatively prime to each other. Their product give you 20. And 3 and 5 are also relatively prime to each other and their product is 15. Correct? So in each of the above cases, you can see that the R and S pair in each case, that is relatively prime, right? However, in our current question, this is not the case. 4 and 10, they are not relatively prime to each other because the GCD of 4 with the 10 is equal to 2, which is not equal to 1. Right? Hence they are not relatively prime to each other. If 4 and 10, they are not relatively prime to each other, here our conjecture is not valid. So we can make this as our condition that whenever we have this result is valid only when we have the numbers R and S as relatively prime numbers. That means the GCD of R with S should exactly be equal to 1 in this particular case. Then only this result would work. However, this is just a conjecture. We have not yet proved it, right? Once you prove it for all the groups, then this becomes the result. Correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.